In this video, we're going to look at what a sparse file is, how you would create one, how to use one, and what platforms they're available in. In a different video, I had used a sparse file as a disk image instead of connecting a physical disk. That method is great as it is quick to create those virtual disk volumes and takes minimal time. And that's just one possible application for a sparse file. Others include using them for virtual machine disk files, database files, and file system metadata files. So stay tuned for more details. Do you subscribe to the philosophy that life and beer are very similar? You know, you have to chill for best results. If so, then subscribe to my channel for more free-flowing beer. A sparse file is a file that appears to take up a large amount of space, but in reality, it doesn't. The bulk of a sparse file is usually filled with zeros, and the file system is smart enough to understand that these unallocated zeros don't need to be written out to disk. So any reads and writes from this sparse file is much quicker than if the entire file was fully allocated. So why use sparse files? In the use case of virtual machines, you can have multiple VHD files, which may add up to more space than the actual disk space available. Another reason is speed. It is much faster to create a 1 terabyte sparse file than creating a 1 terabyte fully allocated file because you're not physically writing all the ones and zeros to a drive. In order to create a sparse file in Linux, we can use the dd command to create it. So first I'm going to use dd to create this 1 gig file with all zeros. And I'm actually going to use the time command to see how long it's actually going to take. So I'm going to do time dd if equals /dev/0, of equals big file, bs for block size is 1k, and count is 1 meg. All right, so 1k times 1 meg is going to be 1 gig in size. So when I hit enter, you're going to see that it's going to take about 4 to 5 seconds for this to complete. So again, you can interpolate this out for a 1 terabyte file. It's going to take a little while longer. All right, then I'm going to use dd again to create another file, but this time I'm going to create a sparse file of the same size. So I'm going to do time dd if equals /dev/0, of equals big file dash sparse, bs equals 1, count equals 0, and seek equals 1g. So this is the key right here, is the seek equals 1g. This is going to basically go all the way immediately to the end of the file, which is 1g. So this is how we create a sparse file. And when we hit return, we can see that this effectively took no time, right? Almost 0 seconds to create. So we know that this is much faster. So let's take a look at the file sizes by doing ls minus lh. And both files are 1 gig in size, right? This is what we expected. Now let's use the stat command and look at the files again. So I'm going to do stat, big file, and then big file dash sparse. This time we can see that the big file uses 2,097,152 blocks, which at a 512 byte block equals 1 gig of space. On the contrary, the sparse file uses 0 blocks of space because the entire thing is zeros, and so they're not allocated. So now we actually see the real difference between a sparse file and a regular file. Another command that we could have used is truncate with the -s option, which specifies the size of the sparse file. So I'm going to do truncate -s, 1t for 1 terabyte, and then just call this bigger file. And so to check on the size of the perceived or apparent sizes versus the actual occupied space on disk, we can also use ls minus s to show the occupied space. So I'm going to do ls minus ls, big file dash sparse, and bigger file. So you see here in the first column, it basically tells you how much space in blocks that this is occupying. And these blocks are actually 1K blocks for this file system. So if you multiply this out, you can see that big file actually takes 1 gig, and the other 2 files are not. They take a fraction of that because they are sparse files. Another way of doing this is using the du command for disk usage. So I'm going to do du -H of big file -sparse, and bigger file. Similarly, you can see here that for the sparse files of big file -sparse and bigger file, they take up 0 space, and then fully allocated file of big file does take up the actual 1 gig of space. Now that I have a sparse file, I can use it as a disk that I can put a file system to and then also mount. But remember that for the mount command in Linux, it only works on block devices and not a flat file like we have here. So in order to make the file system think that a flat file is a device, I need to create a loop device. A loop device would then allow that flat file to be operated on as if it was a block device. So the command to create a loop device is called lo-setup. If we just type lo-setup, it will show us the existing loop devices. So we can see here that there is already a loop 0, which looks like it's the bootable CD for my Linux distro, and then loop 1, which is something that I was doing on a different window. All right, so we will now go ahead and create a new loop device using lo-setup with the -F option, which will find the first unused loop device and then use that as the device. So I'm going to do sudo lo-setup -F big file -sparse. All right, let's take a look at what we just created by doing lo-setup -A again. Now we see loop 2 created, and it is our big file -sparse file. All right, so now that we know that /dev/loop2 is the block device representation of our flat file, we can start to use it as a block device by formatting it with the file system. So I can just do sudo mkfs.ntfs. I'm going to put an NTFS file system on there. -Q, I, L. And then the label, I'm just going to give it NTFS test. And then lastly, the device, which is /dev/loop2. So let's go ahead and verify with disk type to see what we have formatted is correct. So sudo disk type /dev/loop2. And we see that we have the NTFS formatted partition on here. All right, so before I actually do a mount, I have to create a mount point. So I'm going to do sudo mkdir/mnt/hd. And then I can go ahead and mount that volume just like a physical disk. So sudo mount /dev/loop2/mnt/hd. So now HD is mounted and ready to be used. I can just go ahead and put a file to it. So fortune is the program I'm going to run, and I'm going to redirect the output to /mnt/hd/fortune. And let's do an ls-al to take a look at it. And we definitely see that there is a file there. And that's how you can mount a flat file as a file system in Linux. And so when we're done, proper etiquette dictates that we're going to clean up and unmount and release the loop. So sudo umount /mnt/hd, and then sudo lo-setup -d for deleting /dev/loop2. To create a sparse file in Windows, it takes a few more steps. The command that we need to use is called fsutil. And the first thing we're going to do is we're going to create a new file so that we specify fsutil, then the file parameter, and then the create new command, followed by the name of the file to be created, and then lastly, the size of the file in bytes. So I'm going to do fsutil, file, create new, big file, and I'm going to make it 1 gig in size, so 1048.576.000. All right, once that's created, we can take a look at it with DIR to confirm that the file was created. So here it is, and the file certainly is there, and the size is what we expected to be about 1 gig. Now let's take a look at using the fsutil tool to look at the perceived size and actual size on disk. So to do that, we're going to run fsutil, file, layout, and then the big file. And we see at the bottom here that the size is 1000 megabytes, and the allocated size is also 1000 megabytes. So this is not a sparse file as we wanted it to be. We can verify that by using the fsutil command. This time we can use the sparse parameter and the action of query flag. So fsutil, sparse, query flag, big file. And we can see that the file is not set as a sparse file. So let's go ahead and set that file as a sparse file. Once again, we use the fsutil command. This time we use the sparse parameter with the set flag action. So fsutil, sparse, set flag, big file, and then this last value, I'm going to put 1, which means to set the file as a sparse file. And if I use the 0, that would mean we want to unset the file as a sparse file. All right, so we go ahead and hit return. And to verify that we had set the file as sparse, we can run that query flag again by, I'm just going to up arrow twice. And now it does tell us that it is, in fact, a sparse file. So let's go ahead and up arrow and go back to where we look at the layout to look at the file sizes. And once more, we're still using 1 GB on the disk, so this is still not sparse. So we need to take our third and final step of setting the range of the file, which is going to be sparse. So basically, I'm going to do fsutil, sparse, set range, and then big file. And then you tell it from where to where. So I'm going to start from byte 0 and go all the way to the last byte. So 1048.576.000. And so now let's go ahead and check on the allocated space again with the layout command. fsutil, file, layout, and then the big file. And finally here we can see that the size on disk is actually 0 bytes, right? As the entire big file is blank, so it should not take up any space until we actually populate it with data. So in Windows, it takes 3 steps to do. So it is a little more work than Linux, but it's really not too bad once you get the hang of it. Now that we went through all that trouble creating a sparse file in Windows, I'm going to tell you that if you want to use a file as a disk in Windows, you would actually need to use the diskpart command to create a vdisk instead of using the fsutil that we looked at before. Or you can just use disk management and then use a menu to create and then attach a VHD. So in the command prompt, we can just run diskpart. And then once we are in diskpart, we can do create vdisk and then file equals, and then here you have to specify the full path of the destination VHD. So I'm going to do file equals quote c:/users /blue monkey forensics /downloads /disk file.vhd and then end double quote. And then I'm going to tell it the maximum size that this particular VHD is going to be, which is maximum of 1000. These are blocks of 1 meg. So I am essentially saying that this is going to be a 1 gig maximum disk. And then lastly, I'm going to specify the type of expandable versus fixed. So this will grow as we add more content. All right, we hit return, and then I'm going to do select vdisk file equals, and then again, you need the full path. So double quote c:/users /blue monkey forensics /downloads /disk file.vhd and double quote. Now we want to attach that disk, so we need to do attach vdisk. All right, now that the vdisk is attached and selected, we can go ahead and partition and format it. So to create a partition, we can just type create partition and then primary. And now we can format it. I'm just going to do format, and then I'm going to specify a quick format, and then give it a label of whatever you want, VHDX. And lastly, the file system you want to put on there. I'm going to do fs equals ntfs. And now that we have this virtual disk partitioned and formatted, it's ready to be used. So we can just go ahead and assign a drive letter so we can start using it. So I'm just going to say assign letter equals M. And then notice in the background there, a File Explorer window opens up, and we are in the drive M, as we can see here. All right, now we can use this disk just like an attached disk. I'm going to go ahead and create a file, and then just fill it with some text. Save that. And then go back to the File Explorer and right click and get properties for this file. And I see that the file is 32 megs in size and 32 megs on the disk. So that's fine, right? Because It is an expandable disk, so it is not going to take up more space than it needs. So now if I drag another file into this virtual disk, this M drive, for example, I'm going to take this FTK imager binary, which is 95 megs or so. And then I'm going to go and take a look at the properties of that VHD again, the virtual hard drive. And now it's grown to 256 megs on disk. All right, so again, it actually will grow to accommodate whatever we start to stuff into this disk. So one thing to note is that the resulting VHD file is actually not a sparse disk like we created, because the size of the file and the size on disk are essentially the same. Remember when we did the virtual disk, we created a 1 gig drive, and literally when we looked at the properties, it told us it was 1 gig. It's only on the size on disk parameter that it said it was smaller. So I just want to show you the equivalent action of creating a disk file that would be used as a virtual disk on both Windows side and on Linux. One thing to note is that sparse files are a feature of a file system and not necessarily of an operating system. As we saw in this video, I had used Windows and Linux command to create these sparse files. Mac OS will also work with commands similar to Linux. The file system that supports sparse files include NTFS for Windows, the ext3 and 4 file systems for Linux, and then APFS for Mac. Interestingly enough, HFS Plus itself does not support sparse files, but the virtual file system layer of OS X does support them, so you can use them on Macs, even if you use HFS Plus underneath. And for Windows, it's only NTFS. It does not work with FAT or exFAT. For more videos with Linux tips and tricks, make sure you watch these videos here. Click on the blue monkey to subscribe, and remember about the beers. Thanks for your time, and happy hunting.